Alright, so we're going to do the next section of chapter 11, 11.6. We're going to look at writing an equation for a circle. And we're going to be using, again, the Pythagorean theorem and the distance formula to write this equation of a circle. So your homework is on page 685, problems 3 through 6, and number 8. Writing an equation for a circle is another application of the Pythagorean theorem. If you notice in my circle here, I have 2 points labeled. And we know that we have learned the distance formula, and the distance formula was based on the Pythagorean theorem. So the equation of our circle is based on the distance formula, which is based on the Pythagorean theorem. So the first thing I would do is looking at the Pythagorean theorem using from the distance formula that we've learned that we can find the distance between any 2 points. So since we're using that distance formula, we're going to just apply that to a circle. And if you look at the 2 points that we've labeled on the circle, this point HK stands for the center of my circle, and XY can be any point at all on the circle anywhere. So if we're going to write the equation for that circle, what we're going to do is it would be x subtract the center x squared. That's the first part. We're finding the distance, if you remember. So if I'm putting it in Pythagorean theorem, the distance between the 2 x's, the distance between the 2 y's, and that's supposed to equal the radius squared. So if we plug all of these things in, that gives us what we're going to use as the equation of a circle. Alright, so let's look at an actual example. Remember that we said the letters H and K stand for the x and y of the center of the circle, and x and y can be any point on the circle. R stands for the radius. So here we have H and K, I'm saying, is the center of the circle at 5, 3. The radius of this circle is 10. So if I want to write the equation for this circle, I'm just going to put them in where they belong. X subtract 5 squared plus y minus 3 squared equals 10 squared. And then on the second line, I just simplified and said what 10 squared was. These I just leave alone. X minus 5 plus y minus 3 with the squareds on them. So this is the equation for a circle with a radius of 10, and the center of the circle is at 5, 3 on the coordinate plane. Alright, so let's look at one on the graph. Okay, if I look first, I want to find out what is the center of this circle. Well, the center of this circle is at 4 on the x and negative 2 on the y. So there's the center of my circle. It's 4, negative 2. So that's the center of my circle. The next thing I need to know about the circle is the radius. Well, it's a straight line, so I can just count the radius. 2, 4, 6. So the radius is 6. So now I'm just going to take these things and I'm going to substitute them into the circle equation setup that we had. Okay, so I put in my x, I put in my y, and I put in my radius. I am going to do a little simplifying. It's going to be x minus 4, but instead of having the subtraction and the negative, I'm going to switch it to an addition. So y plus 2 squared equals 36. So I can tell that the center of my circle is at 4, negative 2. Okay, this one's asking me to find the center and the radius by looking at the equation. So the radius is probably the easiest one. R squared equals 100. So that tells me that my radius is going to be 10. So I know what the radius is. Okay, so I also want to find out what x and y are, or what h and k, basically, the center of the circle. There's nothing added or subtracted from the x. So how do I write that there's nothing added or subtracted to the x? I'd write it with a 0. I need to know, okay, this is going to be y minus what? So that means this is going to be -5. So the center of my circle is at 0, -5, and the radius of my circle is 10. So this is just kind of using it in the backwards operation. I'm finding the center from what I'm given. Here's another example where I just put it in. I do any simplifying I can, and this would be the equation for that circle. Okay, this one is asking us to find the 2 points on the circle where x would be 7, because it's saying the line x equals 7. So to find this, I'm simply going to substitute my 7 into the equation that they give me for the x. So I just substituted it in right there. See, I took out the x and I substituted the 7 in its place. So now all I have to do is solve the equation. So in that step I just did the subtraction and simplified. Okay, then I subtracted 9 from each side. Now I need to square root each side. And whenever I square root each side, I can get that x plus 2 is 5, or x plus 2 is -5. Notice the line intersects at 2 different places. So that means I'm going to have 2 different answers. So my 2 answers are y, it intersects at 3 or at -7. This one is kind of the same idea. It's just now instead of telling me what x is, they're telling me what y is. So instead of substituting in for x, I'm going to substitute in for y. Do the simplification, and then I would have to square root each side, just like I did on the last example. Again, you can see that it intersects at 2 different points. The one place where it intersects the circle is where x is -2. The other place it intersects the circle is where x is -10. So again, I have 2 different intersection points with that circle. The third thing that we're looking at here is trying to decide whether a point is on the circle, inside the circle, or outside the circle. And we're going to do that by substituting these 2 points, or these 2 coordinates, in for x and y. So I'm just going to put x in, -8. I'm going to put 2 in for y. Okay, so there I've put it in. I'm going to do the calculations that I need to do. And then these are my 3 rules that go with that. If the 2 sides of my equation both equal 100, then that means the point is on the circle. If the value of my 2 coordinates is greater than the radius, then it's going to be outside the circle. And if this value that I'm calculating right here is less than the radius squared, then it is in the circle. So if I finish doing this, I find this side to be 113, and of course this side is 100. 113 is greater than 100, so it falls into this one. If the value is greater than the radius squared, then it's outside the circle. So the point -8,2 is outside this circle that would have this equation. Okay, so that concludes our notes for section 11.6. We will be working on some problems in class tomorrow. But for this evening, since you've watched the video, I would like for you to do problems 3 through 6 and 8 on page 685.